we will head over to Paul. Welcome, Paul.
Thank you very much. So this is a presentation about Darklang. Darklang is a functional programming language that is built specifically for the cloud. So we designed a language which doesn't really live on your local computer. And a large part of that was it being functional. So we're gonna talk a lot about that. I understand there's no Q&A at the end, so feel free to drop your questions into the chat. I'll be keeping an eye on it, and I'll answer it at an appropriate time, possibly immediately when you paste it. But feel free to go for it at any point. So we're going to talk about why we created Darklang. I'm going to give a demo of Darklang and an overview of its main features. I'm going to talk about functional programming. I'm going to talk about a recent rewrite that we had that was from one functional language to another. And we're going to talk about where the project is now, and also a new secret exciting thing at the end. So about me. I previously did a PhD in compilers and static analysis, and then 2011 to 2015, I was the CEO of CircleCI. Took it from sort of nothing to about a couple $1 million, a couple thousand customers, that sort of thing. And then since 2017, I've been at Darklang first as the CTO, and then since 2020 as the CEO. I'll be talking a little bit about that later. So the reason that we're building Darklang, the sort of vision behind it, or the mission behind it, is removing accidental complexity. And accidental complexity, if you've read The Mythical Man Month, you might be familiar with this term. The idea is that you can split the work that you have to do into essential complexity and accidental complexity, and that the accidental complexity is sort of the bullshit that you feel you shouldn't have to do, but that you need to do anyway because computers, code, all that sort of thing. And the essential complexity is the kind of the core, the business logic, the kind of the central stuff that you're actually trying to do. And the idea of doing this came out from when we were at CircleCI. We're looking at building internal tools, and we realized just how much work would go into building internal tools, and how much of an extra product it would be, how much maintenance they would require, how much infrastructure, hosting, security, et cetera, would require to build internal tooling. And it really sort of caused us to do it a lot less than we really should have, and a lot less than would be valuable. So theoretically, the essential complexity of an application is just receiving data, processing data, storing and querying data, and sending data. And these are kind of the core of almost every application. I mean, it's very vague, but the core of every application, certainly every web application, the core of every programming language. This is really what it's about. Think of Unix applications. They receive data from standard in, process it, and write files and send data out. Like this is kind of the core of computation. It's kind of all the same when you think about it. But the essential complexity of what people actually want is the user presses send message, and then the message gets delivered. So everything below that, to a certain extent, is could be thought of accidental complexity. And this is sort of a more realistic essential complexity. It's sort of the business logic of how people actually think about their applications. So we're really trying to get to trying to raise the abstraction of programming, so that it becomes a lot more like this. And where it actually is today, this is the Cloud Native Computing Foundation landscape, and this is all the products and tools that are part of building cloud native applications. Cloud native, obviously, it's sort of a synonym for Kubernetes, but really, like, these are kind of, when you're building applications in the cloud, there's an awful lot of steps, and you need far more tools than you really should. And so we're kind of where we started from this is saying, what if we don't need any of this at all? What if there's just one tool and it's relatively simple? And the other way that we came to this was looking at what it takes to get code into production. So if you write code on your machine and you then want to put code to your users, there's a 40-step CI/CD pipeline. And it's not just CI/CD. We're including the actual deployment step here. We're including the the changes and the commits and the pull requests and that sort of thing. But this entire process of going from code in your machine into code in production is significant, is quite large. So we're really focused on these are low-hanging fruit. How can we make these as simple as possible? So I'll give you a quick demo of building a very simple application in Dark. So we're going to build a HTTP handler. Oh, and I need to log in. So we are building a HTTP handler, and we're just going to do a simple hello world handler where we say hello world. And I'm now going to open it in a new tab, and you can see here this is live on the internet, live on the World Wide Web, having the response that we put in it. And that was all that it took. There's no compiling, there's no making containers, there's no deployment, there's no serverless, there's nothing at all. It's just literally every keystroke that we type is in production, and refresh it again. Here it is. And so the very simple part is that you can do that, but we're going to do a little bit more than that. So we're going to make it we're going to store something in the database. So we're going to make it so that you can say hello user, and let's say hello Paul. And this fails obviously because there's no code here. We deleted it. In practice, you would do this slightly differently. We have tools around slow, safe deployments, but I'm ignoring them for the fast demo right now. So here I'm just going to say hello user. And we include the username. And then we'll open that tab here. What did I do to that? Oh yeah, need to actually put this into it. And then hello user Paul. Okay, that's wrong. So let's go back and we'll put the space in there. There we go. Okay. And what we are going to do is we are going to just do a simple data store. So we're going to make a simple data store, and we are going to store the user in it, and the user, we're just going to store user of type string. And then we are going to call this users, and we're just going to make it so that the users who visit are stored in the data store. So here we are going to just do extremely simple DB set. The value in the dictionary is going to be the same shape as the user. We put this alongside it. So we're just going to put user, and then we're going to have a key, which is going to be the username, and then it's going to be stored in the tables. So this is users. So this is basically what it takes to store data in a data store. There's no creating an SQL database. There's no SQL of any sort. There's no provisioning any sort of data store. The data store gets created automatically. So really there's we're looking at, and this is just a very simple example, and I'm not going to go any further, make a real application out of it. But this is sort of the lowest level, simplest tools, and we have reduced the the creation of the infrastructure and the deployment of the code and the infrastructure to basically zero. And that's sort of the foundations of how we do this. And so these are two of the main Darklang features. One is called the first one we call invisible infrastructure, which is just sort of a degree beyond serverless. It's that not just are there only servers, but that there's not even the visibility of a server. You don't really think about things in terms of infrastructure. And this is sort of what I meant at the start by a functional language for the cloud. The language, in a sense, lives above the cloud instead of being, the cloud being a thing that is built up of servers and infrastructure, and the programming language being an application that runs on a Unix machine that gets put into a container that gets deployed to that cloud. Instead, the language is just sort of a layer sitting on top of the cloud, and you don't really think about its about where this is running or how this is running. You don't need to think about that stuff. The second feature I showed you is what we call Deployless. This is the instant deployments, and it's everything from sort of zero downtime data store migrations, the instant deployment nature, but a lot of tools to ensure that this is safe. So tools including feature flags, and the aforementioned database migrations. Those are kind of all part of what we call Deployless. And the third one is trace-driven development. So you probably saw when we were opening, when we opened the tab in our browser, those live values were fed back into the editor, and we could see them. We could see like the values of the data store and that sort of thing, which I didn't really get into. But that's kind of the other core feature, the trace-driven development. So let's talk a little bit more about the invisible infrastructure. We're putting that idea of invisible infrastructure against the previous idea. This previous idea that you would take a set of tools, you would deploy them, you'd buy them from your cloud vendor, you'd buy them from another vendor, and you'd build your applications on top of these like low-level tools where you needed to either orchestrate them together, or you needed to pull them together with various different SDKs, and each of them speaks a different language. Each of them, your database might speak SQL, your Redis might speak, well, does speak its own language. Kafka speaks its own language. So if you wanted queues or caching or data stores or whatever it is, you would build them with different applications, which create a sort of impedance mismatch between your language and the data, and the way that that data is stored. And in Dark, these are the full list of components. We have a data store, we have cron, we have workers, or backend queue worker. We have what we call REPLs, that are just little tools that if you have a scripts directory where you've written a lot of bash, it's sort of the replacement for that. And of course HTTP handlers, and these are the core aspects of Dark. And so you can sort of think of this as a replacement of whatever infrastructure is below that. You don't know whether it's Postgres or Bigtable or whatever behind the users table. You don't know where the server where the HTTP servers are running. You're not aware, and in particular, you don't have to think of exactly how your HTTP servers are running and what load balancers they connect to, and how to carefully do the dance of switching from one backend deployment to another deployment. This is all sort of done. And same with cron and queue workers. You don't have to think about Kafka, and in particular, you don't have to think about the structure of the data that goes into each of these. There's no serialization involved. You just put a data into your worker, and it's there, and it comes out the other end. You put data into the data store, and it is the built-in canonical format of the language. You don't have to think about what the exact formats of a Postgres table are, and how they map to your language, and whether you have 64-bit ints and Postgres has 48 digits of integers, and how exactly that all intersects. So that's what we've been referring to as as this invisible infrastructure. No provisioning, no infra, no configuring, and in particular, no waiting to get code out there. It simply lives. The code itself lives in the cloud. It lives on our in our database. It's accessible via our editor. There's no Git. There's no GitHub. All of these, sort of any complexity that comes from that, and any learning that you need to do, all that information that you have in your head about how Git works, maybe someday you'll be able to forget it and no longer think about that. And this here is how we like to think about applications. This is not actually part of the product. It is our sort of a future version of how we want the product to work. And the idea here is that rather than looking at your product as a collection of files on disk, as a collection of sort of files and folders and functions within that, or handlers within that, we want people to think of their systems as a live application with traffic overlaid in the sort of directory, in what would be a file system or a set of directories. We want you to be able to look at the actual endpoints and the data stores and the grouping of them, and be able to zoom in or out on the actual on the actual application itself. And what we model this on is when you start a new job and the senior engineer takes you aside and takes you to a whiteboard and starts to draw the architecture of the application. It's always, it's boxes and it's lines between them, and this is what the data store does, and these are the important systems and components. And that's how we kind of want to model applications in Dark and what it means to build applications in Dark. And so this is sort of like our futuristic rendering of where we're going with that. Okay, so that's infrastructure. Or invisible infrastructure. And the second big thing is Deployless. And I talked about how this, this is the step involved in getting code into production. You actually make the change over in the top left, and then you make a pull request and do local code review and a local CI run. And then after it there might be several cycles of that as you get reviews, and then it gets merged into the master branch, and then you do the same thing again, but maybe there's also integration tests and building a container, pushing things to a CDN, updating Kubernetes. And then as we get to the top right, we're actually doing the deployment and we're waiting for that to happen. And then we also enable the feature with a feature flag if you are doing that sort of thing, which you should do. And then in order to remove the feature flag, we go right back to the start and we do a whole sort of, the whole kind of process again. And so we want to reduce that to basically the essential complexity of what it takes to do a deployment of getting code out in production. So you make the changes behind a feature flag live in production. You can run an integration test if you want. You can get a code review if you want. So you can do that iteration in a much tighter loop. And then the actual deployment of it is just enabling feature flags. So as I mentioned, feature flags are part of the Dark application. And so you can enable feature flag, first enable it for your team and then roll it out to 10%, 50% or whatever. And then when it's done, you just sort of tick a box and the feature flag is done. You don't have to go through a whole new pull request, set of commits, a set of code review, et cetera, to be able to remove that feature flag. And in a sense, we're rolling a bunch of different parts of building applications into a single concept, the feature flag. So branches, development environments or different environments, and the existing feature flags and A/B tests, those are all sort of rolled into the single feature flag concept. So where there aren't separate, there isn't a dev environment and the staging environment. Instead, what there is the same stuff running in production with a feature flag hiding it from, and sort of creating that separate environment using the feature flags. So what you get from this, of course, changes are instant. There's no deployment, no CI/CD, again, no GitHub, no file system. And it also, both these features that we talked about, this deployment and this invisible infrastructure, are enablers of our third big feature, which is trace-driven development. So trace-driven development is the idea that when you get a request made in production, it is immediately shown to you in your editor, and it is the live production values that are shown in your editor. So there's this is sort of a bit of a deep dive into it. This is a FizzBuzz endpoint, and it does a FizzBuzz taking the word that's provided in. So you can see that in the middle there, request.params.name. And what you can see in this, there's a bunch of different things. So you can see where the cursor is on the letter I. You can see there that the value of I is 10 on the last iteration of this. So it's going from the range 1 to 10. You can see as well the bits of code that were executed in this trace. So for this iteration of map, which uses I is 10, you can see the if statement that runs, you can see the then, you can see that buzz is going to be the result, and you can see that the other stuff isn't executed and is faded a little bit to indicate that it isn't executed. And then finally, of course, you can see the result of the trace. And you can see that, this is 1, 2 fizz. And as you change the code, that updates, even without having to run it again. And that's sort of the idea of trace-driven development. And you can see there's, things like it replaces the debugger. In the old days, or in how we code today, if you want to debug something, then you need to run it again. You need to either re-enable it with the debugger and then get it to the same state as you're trying to introspect, and possibly you need to build a minimal test case in order to do this, or at least a repeatable test case in order to do this. Or because that's difficult, often what people do is they just recompile their code with a lot of printfs run through it, run it, and then start to grep or search through the printfs to try and see what happened. And essentially Dark is both of these things. You get to see the value at every single variable at every single point, just like a debugger, just like you would in a debugger, but without having to restart it, without having to rerun it, without having to make a minimal test case, because you can use the actual request that came through the system in order to do it. And we found that this trace-driven development idea, this is something that people just absolutely love about the system. And obviously a lot of building Dark is done outside of Dark, and is at the moment it's built in F#. So whenever I'm using F#, I just really miss this. I end up doing some printf debugging, some running a debugger. But what I really want is when I ran that code, put my cursor on something and to see the actual value that it was as it went through the system. That's that's one of the most powerful things in the system, and it's enabled by the other parts of the feature. So this only works because we have the editor. It only works because we have our own programming language, and because the requests are running through our servers. We're able to combine all of these things to be able to make it work. So that's sort of the main features of Dark, and the demo, and why we built it and that sort of thing. And now I want to talk, I believe, about functional programming. So why is Dark a functional programming language? What is it specifically, or what is it like relative to other functional programming languages? So I've been using functional programming in production since about 2011. CircleCI was written in Clojure. Obviously, before that, I had written some OCaml and some Haskell as I was doing my PhD. And since I'd also written a bunch of Elm, and since we started Dark, that was originally written in OCaml and is currently written in F#. So I've really done sort of a trip through every statically typed and also Clojure. So quite a lot of functional programming languages. And so we've taken what I feel is the best aspect of it. I know not everyone agrees with strong static types. I'm a real believer in it. I think that static types are extremely important to making code that scales well, and that is understandable. But we have options and results, static types, first-class functions. Immutable data, I think, is one of the greatest things about functional programming languages. People don't really talk about immutable data as being an important feature of functional programming languages. I don't really understand why that is, because I think it's probably the best feature of it. or maybe tied for the best feature with static types and ADTs or some types. And so Dark also has impure functions. And in fact, we delineate specifically between what is a pure function and what is an impure function, because that's an important part of the trace-driven development. Pure functions don't need to be traced. Impure functions, we store the results of it on the platform so that when you're in the editor and you want to see a trace of an impure function, whether that's like storing something in the database or making a HTTP request or simply like running date.now, those impure functions are kind of a key part of making trace-driven development, and the immutable data and the pure functions are the other key part of this of trace-driven development, because it allows us to rerun code in the browser / editor. As you make changes to your code, you can see what the new versions would be, and that's possible, partially because we know exactly what's pure and what's not pure. So the initial influence on Dark was closure, and in particular, we really modeled Dark on what Clojure calls threading, what most languages call pipes. The idea of taking data and running it through a set of different steps. And that, I feel, gives people a really easy way to reason about applications. And I think that for functional programming, it's something that's sort of missing in, or functional programming, I feel would be relatively unpleasant without it. One of the things that imperative programming has that works really nicely, or that object-oriented programming has really nicely, is method chaining, the idea that you can do A.B.C.D. And I feel that that's what pipelining brings to Dark, and I first experienced this in Clojure and saw just how powerful it could be. It's also in Elm, obviously, and Darklang is very, very similar to Elm. It has that impurity, and obviously it's for the backend, not just JavaScript. But it is a very similar language to Elm. It's a very similar language to OCaml, which very similar to Elm. The first version of Dark was built, well, maybe the second version of Dark was built in OCaml on the back end and Elm on the front end. And while we didn't like OCaml syntax, and there's a lot of sort of cruft to this language, which sort of dates back to the late 90s, we tried to cut away on sort of the object cruft and really focus on the ML side of that. It's very similar, again, to Rescript. No surprise, since Rescript is based on OCaml, and it has a lot of overlap, as Michael was talking about before, has a lot of overlap with Rust, but obviously it is a little bit more functional, a little bit less imperative, maybe significantly less imperative than Rust, and of course is garbage collected, which I personally feel is an essential part of developer productivity. And obviously, Rust has gotten a different way, one which has sort of made Rust not my language of choice. Well, obviously Dark is my language of choice, but Dark, the current version of Dark, is built in F#, and so Darklang is a little bit like F# if we cut out the .NET interaction and the C# interoperability, which is an essential part of F#, but is obviously not needed in a language where the interoperability is mostly done via HTTP. So I don't remember what this slide is for. Maybe I was just going to talk about it. I've done that. Okay, great. So that's the language, and that's the functional programming aspects of it. So finally, I want to talk about, well, penultimately, I want to talk about the status of Darklang. So Dark, in 2017, Dark was a hot new startup. In 2020, we didn't quite land it at the right point, and 2020 happened, and so there was a big oh shit moment, and split up my co-founder, and had to lay off the team, and sort of went down to just me as we had run almost to the end of the cash that we had. And so we've really been a transition since then. In 2021, I did a rewrite in in F Sharp. In 2022, focused a lot on enabling the community to see everything that we were doing, making sure that everything was published on our blog, and that started doing a bunch of Twitch and that sort of thing. And 2023 is going to be the secret new thing, which I'm actually going to tell you right now what that secret new thing is. Briefly, before I do that, we did a quick backend rewrite at one point. It was originally written in OCaml. We wanted it to basically be bug for bug compatible, and so we experimented with rewriting it in Rust. I did about 2 months of experimenting in Rust. Did not like essentially how imperative Rust was and how low level it was, and kind of what you had to do to dodge the garbage collector. So ended up choosing to rewrite it in F Sharp instead. That was supposed to take about 6 months, ended up taking about 20 months. But we ended up doing the transition over to the new system mid June last year, and Dark is now fully written in F Sharp. Is F Sharp good? F Sharp is excellent. It is really a beautiful language. Probably my favorite programming language apart from Dark, and is definitely my favorite functional language apart from Dark. It is a really beautiful language with an excellent type system, and it is a little bit slow to compile, especially relative to something like OCaml, which is lightning fast to compile. And the .NET stack, the .NET web stack, is a little bit odd if you have a functional programming mindset, but once you get past that, .NET is great, moving very quickly, getting faster and better all the time. And you might not know this, .NET is open source, F Sharp is open source, so these are great, sort of like foundational languages to build, and highly recommended for people. So the new secret thing that we are talking about, we've been like relatively public about this in the sense that people who are on our check into our Discord, or people who are people who follow our repo, which is public, can have been able to see what it is that we're doing. But it should surprise absolutely nobody that we are starting to look at or in fact, we are investing deeply and switching almost entirely the project to be something which is focused on how people write code using AI. And what I mean specifically there is that I don't really think that that writing code by hand is going to survive now that the AI has gotten not excellent at writing code, certainly not perfect, but has gotten like very good. And I think that we're, as someone who is working on an editor and a system of writing code, it really felt like the writing was on the wall, and that we were investing our time in the wrong place. So we actually, have made a big switch over and a big changeover to figuring out what is the best way of writing Darklang code using large language models, not specifically ChatGPT, but something along those lines, and to sort of to allow people to write code as quickly as possible, and still have the advantages of Dark, the invisible infrastructure, the deployless nature, the trace-driven development. We think that those are really strong addition to the large language model generated code, or the AI generated code, but we are definitely early in our journey with that. We're gonna see where it ends up. So yeah, that's it. That's what we ran through. Talked about the main features of Dark, how we think about functional programming in Dark, and of course the new secret exciting thing, the AI driven writing code. So yeah, thank you for coming along with the journey. Very much appreciate it.
Paul, very interesting presentation. It was really cool I think that a lot of things and concepts you touched upon in your presentation is really kind of what I experienced myself with the projects you described, and how you write on the you write on the whiteboard and explain all the projects and why do everyone do this, and then all the slides you have, or all the slide you had with all like these different cloud solutions and whatnot. It's like at some point it has to evolve upwards. We can't be not one more solution for the cloud, not one more tool. We need to like get away from that and get productive again, not get bogged down with like the next cool Kafka version or whatever. And of course, I mean, looking at what ChatGPT and other tools in the natural language processing is doing, it is a matter of time before you can start doing more advanced, much more coding with using an AI. I'm looking in the chat. There's no questions. Just a lot of applause. So again, thank you very much, Paul, for your participation. Thank you.